Good evening and welcome to the review for test number 5 for section H1643 of Math 0070 at South Campus. We're going to go through the 18 types of problems that are going to be on the test tomorrow. And once again, these are similar to what you're going to have. The numbers should be different. Okay, so for the first 4 problems, I'm giving you some expressions, 2 rational expressions and then 2 root type expressions. And I want you to tell me where they're undefined at all, if at all. Okay, for rational expressions, those are undefined if the denominator is equal to 0. So for problem number 1, we're interested in when is w squared minus 2w plus 1 equal to 0. Well, this factors the w squared minus 2w plus 1 is going to factor into w minus 1 squared. That's only going to be equal to 0 if w minus 1 is equal to 0, which means that this expression is undefined when w is equal to 1. You don't even have to worry about factoring the expression on top. Let's look at the second example here. Again, it's a rational expression, so we're looking for where the denominator is equal to 0. So where is z squared plus 1, plus 11 equal to 0? Well, if that was true, then z squared would have to be equal to negative 11. There's no real number that we can square that's going to come up to be a negative. That's a topic for another course when we get into imaginary numbers and complex numbers. That's several courses away. So, since this cannot be equal to 0, then this expression is defined for all reals. And that will be, or all real numbers, but all reals is the way I printed it on as one of your choices on this multiple choice test. So again, for rational expressions, they're undefined where the denominator is equal to 0. Unlike that, when we're talking about square roots, we cannot, as we said over here, there's nothing we can square to get a negative number. So there's nothing that square root of a negative number does not exist in the reals. So what we want to look for is where this expression in here is less than 0. So we'd have 16 x squared minus 81 is less than 0. Let's look at the equation version of that first and just find what this factors into. Well, that's a difference of squares, so we'll have 4x plus 9 times 4x minus 9. So these are to be 0 when x is negative 9/4 or x is equal to positive 9/4. If we looked at this on a number line, we would discover that okay, so this would be negative 9/4. This would be 0, and that would be positive 9/4. Above the number line, let's track what happens when for the first factor here, 4x plus 9. Okay, at negative 9/4, it's going to be equal to 0. But for everything less than that, we're going to end up with a negative number there. And likewise, if we're greater than negative 9/4, say 2, or negative 2 for that matter. Negative 2 times 4 is negative 8, plus 9 is a positive 1, so everything greater than that is going to be positive. Underneath, let's look at what happens when x is 9/4. It'll be 0 right there. If it's bigger than that, then of course everything's going to be positive. And then less than 9/4, that whole expression will become negative. Where we have two negatives multiplied together, that ends up being positive. And where we have two positives multiplied together, that's also positive. So it's in between the two roots where this product is going to be negative. So this expression is going to be undefined when x is between or them, or negative 9/4 is less than x, which is less than positive 9/4. That's where this expression is undefined. So we only have to worry if we have two roots. So let's look at the next one here. If we look at, we want 9t squared plus 169 is less than 0. Well, first of all, this isn't even going to factor. But if we look at it, we'll have that 9t squared is less than negative 169. This has to always be greater than or equal to 0. So there is no place that is going to possibly be able to be negative. So when you have a square plus a positive number, that can never be negative, or 0 for that matter. So again, this is going to be defined for all reals. Okay, so for rational expressions, it's undefined when the denominator is equal to 0. For square roots, it's undefined if the expression inside can be negative. All right, the next problem is going to be to simplify a complex rational expression. And you know, that should be self-explanatory why this is complex. Now remember, when you have two fractions with different denominators, if you want to add or subtract, you have to find the least common denominator and change each fraction into its equivalent. So I just use a double line here for emphasis. This first fraction, 1 over m, we're going to multiply it by m minus 1 over m minus 1. That'll be minus m over m times m over m minus 1. And you're not going to do any canceling here because you have to change it to the same denominator. Okay, likewise on the bottom, in this case it's m plus 1, so we're going to multiply m plus 1 over m plus 1 times 1 over m. And then this time it's plus. And it'll be m over m again. Times m over m plus 1 this time. Okay. Now on the top here, our new numerator is going to be m times m minus 1. And then on top of that, for its numerator, we're going to have m minus 1 minus m squared. Our new denominator is going to be m plus 1 plus m squared, all over m times m plus 1. So we'll have minus m squared plus m minus 1 over m times m minus 1 times, and remember, when we divide by a fraction, that's the same thing as multiplying by the reciprocal, so we flip that. So we'll have m times m plus 1 on top, and then m squared plus m plus 1. Now we can cancel these two m's here. That'll leave us then in the end with m plus 1 let's factor out the minus here, so it'll be times m squared minus m plus 1. We can park the minus sign out front. And then the denominator is going to be m minus 1 times m squared plus m plus 1. There's nothing that's going to cancel, so just leave it like that. There's no good reason to take the time to multiply it all out again. We always like to keep it factored there in case we can cancel it. But that's how you would do this type of a problem. Okay, for the next 4 problems, you're just doing the operations and then simplifying your answer. Okay, so we've got one fraction times another fraction. The thing there to do is to always get everything factored out and see what you can cancel and clean up and make things easier. So 7q squared over, you'll notice that all 3 of the coefficients here are divisible by 7, so let's factor a 7 out. And that would leave us, well, we'll do it in all the steps, I guess. Q squared plus 6q plus 5. This will then factor into q plus 1 times q plus 5. Okay, so that fraction times our second fraction. The numerator factors into, since it's a difference of squares, it's q plus 1 times q minus 1. And then 4q for the denominator. Okay then, the 7's here cancel out. Q goes into q squared, q times. So this just ends up being q here. And these q plus 1's will cancel out. So we end up then with q from this denominator times q minus 1 from the second numerator, pardon, I think I said that wrong. And then we'll have 4 times q plus 5. Okay, nothing else can be canceled out. And again, don't waste your time multiplying things back out again. This is how all your possible answers are going to look. Okay, so that's how you do that one. This one, we have an extra step, because when you divide by a fraction, you multiply by its reciprocal. So this is going to become s squared minus 9 over 6 times, and then our denominator becomes our numerator. And again, we can factor a 3 out, so this will become 3 times s squared minus 3s plus 2. And then we'll have that s cubed minus 27 goes to the denominator. Okay, now let's do some more factoring here. S squared minus 9 becomes s plus 3 times s minus 3. That'll be over 6 times 3 times, this is going to factor into s minus 1 times s minus 2. That'll give us our middle term of negative 3, negative 1s and negative 2s, and then negative 1 times negative 2 gives us that positive 2. And then our denominator is the difference of squares. Pardon me, this is a cube. I made a mistake there. Okay, difference of cubes. We know that formula as well. That's going to be s minus the cube root of 27, which is 3. Then times, it'll be s squared plus 3s plus 9. Okay, so 3 goes into 6 2 times. S minus 3's cancel. And so this ends up being s plus 3 and times s minus 1 times s minus 2, multiplying all of our factors in the numerator, and then the same thing for the denominator, and we'll end up with 2 times s squared plus 3s plus 9. Okay, so the only difference here is because it was division, we flipped the second fraction for rational expression first. All right then. Then for something a little more interesting, again we need to get a common denominator. Well, it turns out that p plus 2 times p minus 2 is equal to p squared minus 4. So our least common denominator is going to be p squared minus 4, which is the same thing as p plus 2 times p minus 2. When we multiply through by that least common denominator, it's going to get rid of all our denominators. So this first number, the p plus 2's will cancel out, so we'll have p times p minus 2 plus 3 times, here the p minus 2's will cancel out, so this will be times p plus 2, and then minus the p squared minus 4's will cancel out, and so we're left with just p minus 4. So let's do our distribution here, and we'll get p squared minus 2p plus 3p plus 6, and then we bring in that minus sign and we get minus p minus a minus 4 is a plus 4. Okay, there's only one p squared term. Negative 2p and plus a negative p is a negative 3p, negative 3p plus positive 3p. All these just cancel each other out. And so we're left with 6 plus 4. So the answer is going to be p squared plus 10. And that's as simple as it can get. Well, wait a minute. You know what? I did make one mistake. We don't actually get rid of these. This isn't a rational equation. My apologies for that. We're still going to have p squared minus 4 on the bottom. Or you could write that as p plus 2 times p minus 2. You'll need to double check that, I guess, on the test. But since this is not an equation, we're just putting it over a least common denominator. Okay. Now, I'm not. We should have p squared minus 4 there. And p squared minus 4 there. Okay. And then also the p squared minus 4 there. And then all of this is actually over p squared minus 4. Okay. So we end up with this p squared plus 10 over p squared plus minus 4. Okay. Now, we're multiplying two square roots together. We can, in fact, write that as the square root of the products. So we could have a single square root, and then we'll have 4 times 20, or 80, and then x squared times x to the 6th is x to the 8th. We want, in order to simplify this, we want to see how many what perfect squares we can get out. So 80 is equal to 5 times 16. Okay, we're still taking the square root of that. So that's going to give us what? 4 times, pardon me, the square root of 5 times. This would be 4 x to the 4th squared. So we'd end up with the square root of 5 times the square root of 4x to the 4th squared. We'll switch sides here. We're going to have the square root of 5 by itself here. There's no problem with the square root of 4 squared just being 4. But we don't know whether x is positive, is non-negative, or negative. Because we've raised it to an even power, either possibility would work. Well, let's see. This is so tricky. Half the time we didn't used to worry about that. This ends up being 4 times the absolute value of x to the 4th power times the square root of 5. Now, yeah. Actually, No, we'll just leave it at that. I don't want to get into a big philosophical discussion. This could easily be written also as 4 x to the 4th times the square root of 5, because it doesn't matter whether x is non-negative or negative. When you raise it to an even power, everything's going to be the same. So, okay. So one way or the other, you'll run into these on the test. Okay. Now I promised you'd see some rationalizing the denominator here, and that's what's going to happen in number 10. We could rewrite this as a square root of that fraction. So we get 48 u to the 8th v cubed over 15 u to the 6th v to the 7th. Okay. What will end up here, 48 is equal to 16 times 3. And then we have u to the 8th v cubed (15 is 5 times 3) times u to the 6th and then v to the 7th. Okay. Obviously the 3's are going to cancel out. U to the 6th goes into u to the 8th, u squared times. So that'll get rid of the u in the denominator. And likewise, v cubed goes into v to the 7th, v to the 4th times. So we end up with 4u, 4 times u squared here on top, because 16 is 4 squared, and u squared is u to the u squared, so that takes care of that. And then we'll have 5 times v squared squared for our v to the 4th. So that's going to, the numerator is going to come out as the square root of 4u squared is just 4u. And the square root of v squared squared is over v squared. So inside here we're going to have 1 over 5. We don't want a square root of 5 in the denominator. So what we're going to do is we're going to multiply top and bottom by the square root of 5. So in essence, we're just changing the form of this number to get rid of this square root. The square root of 5 times the square root of 5 is just 5. So this becomes 5v squared. And then the only thing we'll have left under the square root sign then is just the square root of 5 in the numerator. And that's what that would be equal to. So that's what we mean by rationalizing the denominator. You have a square root of a non-perfect square, you multiply it by that square root so that you end up with a square root squared. That gets rid of the radical, but it moves it up to the top, into the numerator. And mainly we do that because everybody seems to want to, try to approximate this. If you put the approximation in the denominator, you introduce more error into the final calculation. Of course, us pure mathematicians just leave it as the square root of 5 and we don't have to worry about it. Okay, and then the last one of these. What we're going to do is in each of these simplify it, and then if we have common radicals, we'll combine like terms. Okay, so we have 4 times the square root. 18 is going to be 2 times 9, so we'll have 9x to the 4th here. Minus 5 times okay, the square root of 3 times 9x to the 4th. Well, 9 is okay. And then x squared times the square root of 7 squared. Okay. So, what we're going to end up in the first term here, this becomes 2 times 3x squared minus 5 times the square root of 3 times 3x squared plus 7x squared. Okay, so 4 times 3x times the square root of 2 minus 5 times 3x times the square root of 3 plus 7x squared. Oh, I'm sorry. That's x squared and that's x squared. Squared. All right then, so we end up with 12x squared times the square root of 2 minus 15x squared times the square root of 3 plus 7x squared. Well, we can factor an x squared out. And we'll have x squared times 12 times the square root of 2 minus 15 times the square root of 3 plus 7. Okay. And that's that, because these are not like terms. We can't combine any of them together. All right then. The next three problems is where we're solving equations. In 12 and 13, we will be getting rid of the denominators. Okay, our least common denominator here is t squared. So if we multiply everything through by t squared, 1 times t squared is t squared, minus 3 times over t times t squared, one of the t's will cancel, and we end up with minus 3t. And then on the other side, we just lose the denominator. So if we bring everything over to the same side, we get t squared minus 3t minus 4 is 0. This factors into t minus 4 times t plus 1. And again, minus 4 times positive 1 gives us a negative 4. Negative 4t plus 1t is negative 3t, so that works out. So this means that either t is 4 or t is negative 1. Now, the thing we would have had to have watched out for, in the original equation, these are undefined if t is 0. So if it ended up that one of our answers was t is equal to 0, we would have to throw that out. Okay, let's move on to 13. Here the least common denominator is w plus 8 times w minus 2, which is w squared. 8 minus 2 would be plus 6w minus 16. Okay, so when we multiply the first term by our least common denominator, the numerator will end up with, left over, is 3 times, we have w plus 8, so it's w minus 2 that's going to be left. Minus 2 times, and here we'll have the w plus 8. And then that's going to be equal to w squared plus 6w minus 16. So over here on the left, we get 3w minus 6 minus 2w minus 8. That's equal to w squared plus 6w minus 16. Okay, 3w minus 2w is just w, and then minus 6 minus 8 is minus 14. Okay, let's subtract w and add 14 to both sides. And we will end up with 0 is equal to w squared plus 4w minus 16 plus 14. That's going to be a minus 2. Now, are there, well, for this course, we're going to have to say we probably can't solve this. Let's see, did we get oh, that's the problem. This should be minus 16 because we had negative 2 times positive 8. Negative 6 and negative 16 is actually negative 22. So we want to add 22 to both sides. I knew this had to work because this is one I pulled from the book. So this becomes a positive 6. 22 minus 16. Okay. So that's going to factor then into W plus, well, okay. All right, let's stop and think here a second. Minus 16 minus 22. Well, shucks. What positive factors of 6 add up to 4? Well, there aren't any. This is going to be either 1 and 6 or 2 and 3. Oh. Well, let's see. 6 minus 1 is actually 5. So yeah, it does work. W plus 1 or W plus 6 is equal to 0, which means that W is equal to negative 1 or W is equal to negative 6. We would have only had problems at negative 8 or positive 2, so those are both good. Okay. Just goes to show you, you got to watch what you're doing and double check each step of the way. Even us old fogies with master's degrees in math can make mistakes. Let's look at this one. If we bring, we want to start with, we want to have a radical on one side and everything else on the other. So we'll move that negative 6 to the other side. We get the square root of 3x minus 1 is equal to 6. Square both sides, and we get 3x minus 1 is equal to 36. Add 1 to both sides, and we end up with 3x is equal to 37. And divide both sides by 3, and we end up with x is equal to 37/3. This is undefined when let's see, it's greater than or less than. If x is less than 1/3. So, since 37/3 is greater than 1/3, we don't have to worry about it. If this had been a positive 6, when we bring it over to the other side, we'd have a square root is negative 6. That's not that doesn't work. That's a contradiction. So there would be no solution. That's something that you have to watch out for. Because when you multiply through by the variable, that gets rid of the problems that of being undefined, because we get it out of the denominator. Once you square both sides, it doesn't matter if you've got a square root equal to a negative, which is an undefined situation. That's called, what do they call that? When you square both sides, or when you multiply through by the least common denominator, you're introducing some possible false answers to the original problem. There's a term for it, and it escapes me at the moment. But that is a problem, and extrapolate's not the right word, but you introduce extraneous solutions. Yeah. Okay, so now the last 4 problems on your test. A guy is riding in an airplane. We want to know how fast is he flying, given that he could do this distance with the wind, this distance against the wind. Well, we know that